Hello everybody and welcome back. So in this next lesson I'm going to talk about logic. So what I mean by logic is sort of logic statements. In other words, what we're trying to do is run certain functions to assess or check something and return a boolean. So is it true or false, right? And then based on that result, using those in if blocks, so if else statements, in order to perform certain functions based on those checks that we've run, right? So this is a very common thing to do within coding, and of course if you've done a lot of coding before, then you'll know exactly what I'm talking about. So in Python we have all the basic logic operators that you'd expect to find. For example, if we just set a few variables, so I'll go x equals 2, y equals 5, right? So we've got two variables and now I can assess these. So I can say x greater than y, okay? And then this is going to return a boolean depending on the value of x and y, okay? So x greater than y is going to return false because obviously x is 2 and y is 5, right? I also have less than, so we can perform that same check, and obviously that will now be true because x, so 2 is less than 5. We also have the greater than equals to, right? Which again will still be false, but obviously if x was actually equal to 5, then when we say x greater than y, it's going to be false, but x greater than equal to y will now return true because x and y are actually the same, which means they're not greater than, 5 is not greater than 5, but 5 is equal to 5, okay? So you can do greater than equals to, or you can do less than equals to, all right? And it is in this order, if in case you're wondering, so just if you've never done this before, it's specifically you say greater than, equal, less than, equal, okay? You can't do it the other way around, equals greater, okay? And then we also have equivalency checks, so you can say x equals y. Now please note, if you've never done this before, this is one of the very common gotchas that get most people that are new to any sort of programming. Checking that something is equal is not the same as setting something to be equal, okay? So saying x equals y is asking the question, is x equal to y? And that will return a statement either true or false, in this case true. However, let's say I said x is equal to 2, right? So we're now back to where x equals y would be false, right? But if I said x equals y, this is not checking whether x is equal to y. This is saying x is now equal to y. So it is setting a new value for x, okay? So even though here I've set x to be equal to 2, after this statement, it doesn't return a boolean, and in fact x now equals 5, okay? So a single equals is setting data, and double equals is querying whether something is equal to something else, right? And then we also have not equals, which is an exclamation mark and an equal sign, right? So this is saying basically if it is equal, it will be false, but if it's not equal, then it will be true, okay? So in this case, it's false because x does now equal y, because we literally set it to equal y. So now they are both 5, and therefore, is x not equal to y? No, it's not. It is equal, okay? Right. So these are our basic logic operations, and we're going to use this very often to, as conditions to essentially trigger an if statement. So we're going to check one thing compared to another, return a boolean, and then say, okay, do this if this is true, or if that is false, then do something else, okay? But sometimes we want to take it a step further. Sometimes one logic operation is not quite enough, okay? So yes, we want to check that, let me just set my x back to 2, and then I'll also create a z. So z equals, I don't know, 7. Okay. And I'm just going to move over to this side just because it's easier, right? So we want to now check, and we say, okay, so I want to make sure if x is less than y, okay, so that's true, but I also want to make sure that z is greater than y, okay, and I want both of these to be true. So even if x is less than y, but then, you know, maybe my z is lower than y, then I want the whole thing to return false, because I want to check these two things, and only if both of them are true do I then want to proceed with the first block of my if statement. So in order to do this in Python, it's very, very intuitive. You just type the word and, okay? So x less than y, and you'll see any of these sort of functions, these keyword functions that appear in Python will pop up purple, so you'll see, you know that you've entered something that is actually a reserved keyword. Okay, so we say x less than y and z greater than y, and that's going to return true. Okay, but if we went to now set z to be equal to 1 and then ran that same statement, it's now going to say false, because x is less than y. Okay, x is 2, y is 5, so this part of the statement is true, but this part, z being equal to 1 is not greater than 5, so this part is false. And with an AND statement, it basically says both sides need to be true, otherwise I'm going to return a false. So in this case, one side's true, one side's false, it will return false. Now we also have the same thing, but with an OR. So with OR, what that is saying is if either side is true, either one of them or both, it will return true. And it will only return false if neither side is true at all. Okay, so in this case it's true, because it's saying, well, this one's true, this one's false, so I'm going to return true. Okay, and that's quite understandable, you know, because that's literally how we use the word or. It's like, well, is this true or that? And you go, well, yes, one of them is true. Okay. And then very similar to how we have the equals and then the not equals, so there's a sort of a negated equivalent. There is also another reserved keyword, which is not. Okay, so we can use the same statement where we can say, okay, so x is less than y, and then we can say and not x is greater than y. All right, now I know that sounds a little confusing, but what it's basically saying is this is true, so this must be true, and this must not be true, in order to successfully get a true out of this statement. Okay, so this will be true in this case because x is less than y. So tick, yes, that is true. And then is 1 greater than 5? No. Well, for this, with a not, it's saying this must not be true in order to return a true within this AND statement. And so both sides are true if you include this not. Okay. And you can do the same thing with OR, so you can say OR not this. So there's a lot of combinations of this, and you can also stack this up multiple times. So you could say x less than y and z greater than y, or not z greater than x. And then, you know, obviously sometimes it gets a bit confusing, so you have to go through very carefully and figure out what you're actually asking for. But if you're very logical about it, that's why they call it logic statements, then you'll be able to get the right result out of it. Okay, and the whole result is basically searching for this true or false, so that we can use that, feed that into if or else statements. Now, before we move on to the actual if else blocks, I just want to show you one other logic statement which is useful, but it only really comes in handy in very specific cases. Maybe if you get much more advanced into Python, you'll use it a lot more, but I've found that within Houdini, I'm using this very rarely, but it is good to understand because, you know, it's very different to using equals. And that is the is statement. And then there's also an equivalent is not. Okay. Now, is on the face of it seems very similar to equals. Okay. In other words, you're checking if something is equal to something, that's equals. But with an is, what you're checking is whether something is the same object. Okay. Not is pointing to the same object, not has the same value, but literally is the same thing. And what I mean by the same thing is that in Python, when you refer to something, for example, when you store a variable, it has an ID. It basically has a memory footprint. And if two different variables are pointing to the same object, the same memory footprint, then they are the same object. Okay, so let's do this as a bit of an example. So I'm going to be using as a case study here. I'm going to show you the who.node. Okay, so this is a class. I just want to, before I carry on, I'm going to point out that this little section is going to get a little more advanced. So those of you who are very beginner, don't worry about this one too much. Try follow along, but if you get stuck, just don't worry, because this is not that vital at this point, and later on when you understand more you can come back and redo it. But I know that some people listening might be a little bit more advanced, and so I want them to understand this is statement as well. So I'm going to get a little more advanced for a second here. Right, so we've got our class, our node, who.node class, right? So I'm going to store this in a variable. So I'm just going to create a variable called foo, right? So, and if I say now, foo is who.node, right? That's going to return true. But it's only going to return true because this variable is storing the actual class, a reference to the class, not an instance of the class, right? That's very important to understand this distinction. An instance of a class, you would have to use, there's a few other statements you can use to check if something is an instance of it, including the function isInstance. But this is statement will not be true for that. So if I just say, well, I'm going to store it in X here, so I'm storing a reference to this node, which if I print X, you'll see here, this is an instance of the who.node type, okay, the who.node class. But now if I say X is foo, that's going to return false, because the one is an actual reference to the class, the other one is an instance of that class. Okay, now here's another important little test. If I have a different node and I pull that in here and maybe store this as y, so y equals who.node geometry2, and so X is referring to geo1, y is referring to geo2, then obviously we can expect that this is going to return false, okay, because they're referring to two different objects. But what if I said z equals geo1? Okay, so we say X is z, right? Because X is referring to geo1, it's an instance of the who.node class, but referring to geometry1, and z is doing exactly the same thing. So we say X is z, and we get a false, right? Now this is because running this function and referencing, so here when we ran it referring to geo1, and here when we ran it referring to geo1, these are two separate functions referring to the same node. Python doesn't care that this is the same node, that it's the same object within Houdini. What it cares about is whether it's the same object within Python. Okay, so the memory footprint for these two references to the node is different. It's basically like if I had to say to you, okay, if I pointed to a location, you know, maybe like your house, and said, okay, draw a map. Draw me a map to your house. And then I told a different person, draw a map to that same house. Even though it's referring to the same location, it's two different maps drawn by two different people. They will be drawn slightly different. The scale may be different. The route may be different. It's basically the same location, but a different map. Creating an actual instance of it. So here, if I had to say that y is equal to z, right? Now if I say y is z, that'll return true. That's because it's not two different maps. It's like I've taken the map that you drew to your own house and then told person y, okay, to photocopy your map. Not draw their own map, but actually copy your map. Now those are two identical maps, okay? Yes, it's a copy of it. It's stored in a separate variable. There are two copies of it, but it's the same map, not two different maps to the same location. Very, very important to understand that, okay? And there is an ID function in Python that you can use to check these things. So if we say IDX, it's going to return the sort of memory footprint ID of this variable that we've stored. Now if we say ID Y, you'll see that these are two different numbers, okay? So when we say X is Y, it's going to say false. But then when we say ID Z, right, you'll see that this is the same as ID for Y, okay? Because they were set to be a copy of one another, okay? Now, obviously, if we're setting Y equals Z, then we know that Y is Z, but you'll see later on when we build code, there are a lot more complex ways that objects can kind of be copied. You know, this may be in some other if statement or through some kind of loop. So then we've stored a copy of something in a variable, but later on we need to check whether that has successfully happened. You know, it could be happening inside of a function or something else. So this is statement does become relevant later on when we don't know whether something is an actual copy of something else, right? Now if we said, I'm going to just overwrite my same variable. In fact, no, I'm going to use ABC now just so we don't get too complicated. If I set A to be equal to who.node, not running this function and returning an instance of the node, but the actual who.node class. Okay, so I'm just setting A to be a reference to that class. And then I set B to be a reference to that class. Now when I say A is B, this is going to be true. So unlike here where the two equal references to the same object returned false, and we had to set them to be equal to one another in order for this is statement to be true, it's different with the classes because this reference to the class, it already exists. It's not a function that's creating it. This is an object within Houdini already. This is a class that exists. It's an object. It has an ID. And so setting A to be equal to that object and then setting B to be equal to that object is going to return the exact same memory footprint, right? So we can say ID who.node, and you'll see that that has its own ID. And then when we said A, it stored that exact same ID. So setting B to be equal to that is also just storing that same ID. Okay. Right, so I hope that clears that up a little bit. Just know that there's one more thing I want to point out is that the checking equivalency, so not this ID check with is, but actually the equals and the not equals. Within your classes, it's the same thing as I mentioned with normal like basic mathematics. You know, your plus and minus and multiplication. Yeah, you can check numbers very easily. You know, we can say very easily is 4. Does 4 not equal 7? And it's going to say true. But if we had to do that with classes or instances of classes, then we have to actually have a magic method coded into the class, which we will discuss later on. So you need your actual equals and not equals function built in order to check whether something is equal or not. So you can't just say, here our x is a reference to G01 and our y is a reference to G01. So now we say x equals y. Okay. The reason this is able to return true and actually tell us correctly that this is the same node, a reference to the same node, is because inside of this class there is an equals, so an underscore eq function that runs a check and double checks that it is a reference to the same node. Okay, so I'm going to go into this in more detail later on, but if we just say dir and then who.node, it's going to show us a list of all the functions, and you'll see up at the top here, one of them is this underscore eq. Okay, so this magic method. So this is a function that tells Houdini tells Python how to check one node against another with this double equal sign. If this function did not exist, we wouldn't be able to do it. Okay, so if we build our own class and we don't build that equals, then when someone references your class with, let's say it's stored in X, and then they say, is this equal to Y? It's not going to know. It's going to just spit out an error saying, I don't know how to do these two things, Okay, so right, we're done with a little bit of an advanced section of that, so I hope the beginners are excited about learning things like this in the future. Cool. So now that we've got some Boolean statements out of all of this, let's discuss how we're going to use it. Okay. Now, the primary way of using Boolean is with an if statement. Okay. So if is basically just saying check something. So if this statement that you give me is true, I'm going to run a block of code. Okay. So again, let's maybe just simplify things. We'll store our x equals to 2 and y equals to 5 again. Okay. So I keep using these same numbers just so we're nice and consistent. So I say if x less than y, and then you just put a colon. Okay. And then when we hit enter, we need to tab in and then do something. So I'm just going to say print hello. Okay, just for the hell of it. So now when I run this, it's going to say x is less than y. That is true because 2 is less than 5. So then it does what I've told it to do. Okay, and if I swapped it, in fact, you know what? I'm just going to pause here for a second and show you guys that for stuff like this, when we're running multiple lines, it's really much easier to use this Python source editor. So instead of trying to write multiple lines of code in here, I generally like to use the Python shell. I mean, obviously things print to it, and I like to use it for single lines, but when we get more complicated, it's so much easier to write in here. So now the difference between these two is that when I type in here, if I write multiple lines of code, it doesn't, when I hit enter, it's not running anything. I have to click apply for this to actually do something. So I can actually type my whole statement here and I don't lose the statement. I can go back and alter it after hitting apply, right? Now obviously x is not defined here, so we need to say x equals to 2 and y equals to 5, okay? And then it's going to run that. Okay. Now, I just want to point out one little thing. It seemed to have worked here, and maybe they fixed it, but I just have an old habit of always importing the Houdini module into this. So, Who is a module that has all of the Houdini functions built into it. Okay. And it runs automatically when you run Houdini. Okay. In the Python shell, it's already imported and instantiated straight away. But there was a time, and I don't know if it's fixed yet, where this Python source editor, if there was an error, if something broke, then it would somehow drop this Houdini module. And then it would, even if you fixed your mistake and hit apply, it would keep erroring because it now doesn't have this Houdini module. So I always just import Who and then continue with, because then every time you run it, it re-imports Houdini. So even if it has broken and has dropped, it will just re-import. Maybe this is unnecessary now, but better safe than sorry. Okay. So anyway, back to our thing. So we now have our values here, our variables stored, and we're checking if x is less than y, then print hello. Okay, but what if we now go and set x to be equal to 7? Now when I click apply, nothing happens, because it literally reaches this statement, says this is false, and if this is false, then everything that is tabbed in here will not happen. So we can do something else here. We can now set z to be equal to 3. We can do something else. I don't know, maybe, print, well, let's print z, okay? So because we've just created it, so we'll print it. So all of these lines of code will be completely ignored because this statement is false, right? And then only if this statement becomes true again will it do any of that. Okay. Now we have a follow-up to this if statement, which is the else. Now an else statement is kind of just catching, it's an additional block that says, okay, well, if this is true, then do this, and then if it's false, then do this block instead, right? So it will never run both. It will only do the one or the other. Okay. So this is only, I mean, sometimes you will just use an if statement because the else is you want nothing to happen. Okay. So if you want nothing to happen inside of an if else block, you can use the word pass. But this is a little bit redundant. You don't ever have to really do this where you say if this, then do that, else pass. Because this is saying else do nothing. But you might as well just remove this entirely, because if this is not true, then it still does nothing. Okay, so you can do it that way. But I sometimes, you'll see I use this pass when coding, because sometimes I know that later on I'm going to want to do something else. So I kind of leave this in as a like a placeholder to remind myself later to come and replace this nothingness with something, some kind of maybe printed error, or just maybe setting a variable, or maybe you can do later I'll show you guys how to do pop-up error messages or whatever. So you then know that, okay, later this needs to be replaced. Okay, so basically pass says continue and do nothing, right? So if we now do something else here, so let's just print nope, and we'll set z to be equal to 8 or something, okay, and print z. So we can do a whole bunch of other things inside of this statement, okay? So now when I click apply, it says hello 3, because obviously this is true, so it ignores this block entirely. And then when I change x, now it says no and 8. Okay. Now there is one more step to this, because we have our if, we have our else, but what we can also do is check another statement. So we say, these are called elif statements. In other words, it's a short way of saying else if. So it's basically like doing this else over here, saying, so if this is true, do this, otherwise, but instead of just saying otherwise, no matter what, as long as this is false, if this is false, then do this. Instead, what we're saying is, if this is false, check something else, and then if that's true, then print this, and then we can have lots of them stacked up. So let me show you as an example. So we say elif. So in other words, if x is not less than y, then this will be false, so it moves to here. Then it checks our next statement. So unlike the else, we actually do have to give it another statement, just like the if. So then we say, well, then is x equal to y, then do something else. So print equal, and then z equals 0 or something, okay? And print z. And then we can say elif x greater than y, then print something, and z equals 5. Print z. And then, okay, in this case, actually, the else statement is really redundant, because these are the only three possible outcomes. X is going to be less than Y, equal to Y, or greater than Y. So, but I just wanted to show you that you can stack up multiple elifs and then finish with an else as well. So what this is going to do is run through this in order. Okay, it's going to reach the first statement and say, is 7 less than 5? No. So none of this happens. Moves to the next statement. Is 7 equal to 5? No. So skip all of this. Move to the next statement. Is 7 greater than 5? Yes. Okay. So print the word something, set z to be equal to 5, and print z. So it's done exactly that. And then if this was false, then it would do this. Now, this is obviously then a bad example because, like I say, these are the only three possible outcomes. So no value of these two would ever trigger the else statement. So actually, technically here, you could rather put in an else and take this away. Okay, sorry, else. Okay, so then it would do the same thing. Okay. But if there are other scenarios where you could have multiple outcomes, and what you want to do is check 2 very specific ones, or maybe even 3 very specific outcomes, and then everything else has an else statement attached to it. Okay. Again, you also don't even have to have the else statement. You could say, if this, then do this. If this, then do that. And then if you don't have anything, then it's going to do nothing. So if neither of these two are true, then it will just bypass it entirely like this. It does absolutely nothing. And then only if we set this to be equal to 5 will it run this one, and less than 5 will run the first one. Okay. So there we have it. These are our if, elif, and else blocks. And also you now know how to use the words pass as well. Which is kind of useful in elif and if statements. And then we've discussed all of the Boolean, all the logic ways to get a Boolean statement so that we can run our if and else statements. Okay, so I hope this makes sense for those who've never done this before. If you are confused, I mean, just go over this a few times. You will use this all the time in coding, so this is really something that we need to understand. But as we move forward, we're going to do it practically, and I'm sure it will make more sense. And then I hope for those who are a little bit more advanced that you learned something here, particularly about the is section over here, because this is actually quite useful. All right. So thank you very much, and I'll see you guys in the next lesson.